So let's try the following integral. So I am going to assume that by this point you have been introduced to the idea of a U-substitution. Also, we know that the derivative of tangent is secant squared. So let's use a couple of these facts to make a U-substitution. So I would allow U to equal tangent of x thirds. So if that's U, let us establish du, the derivative of this. So we're ignoring this for now. We're looking only over here. So the derivative of tangent is going to be secant squared, and then we keep the stuff inside, but then we multiply by the stuff inside. Now this here, that's the same, just FYI, that's the same as 1/3 x. And the derivative of 1/3 x is just 1/3. And of course we attach a dx. So this is what we call the chain rule, where you apply the derivative of the outer function, tangent, which is secant squared, and then you multiply by the derivative of the inner function, 1/3 x, which is of course just 1/3. I'll put parentheses here. Now, let's go back to the main problem, and let's see if we can rewrite all of this instead of x's into u's. So let me carry my integration symbol. Now, instead of tangent of x thirds, what could replace that? Well, tangent of x thirds equals u. So by substitution, that's what that becomes. How about this? All of that is one piece. Secant squared x thirds dx. I see that I have that here and I have that there, but that 1/3 seems a bit out of place. So what I'm going to do is I'm going to multiply both sides by 3, because this 3 immediately knocks this out. And so now I see that all of this here, which is this there, is the same as 3 du. So 3 du needs to be placed in here. So watch what I do. I'll place the constant 3 out to the front, and I'll just deposit the du inside. So now I want you to forget this and to forget that. Just look at this here. What is the antiderivative of u? Well, that's just going to be u squared over 2. And then of course keep the 3, multiplication, and don't forget your plus c. So we are essentially done. Let's just now bring in the value of u into this expression. And I suppose we can clean this up just a little bit. And of course, carry your equals, 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 equals. So the goal was to evaluate, or rather to perform this integral, and this is the finished result.